So now I'm going to do part 3. For the rest of the video, I'm just going to use the table feature on my calculator to get the y's, because it just takes too much time, and I prefer you getting the y's using your tables rather than being inefficient like I did for the first part of finding my y's. So in this part, I need to do maybe 28, 32, and 34, and maybe 22. So let's start with your problem is I should have assigned 20. I assigned 23. So your problem is 23. Let me do 22. That's inspired by 23. If I was doing problem 22, immediately I'd look at the exponent. Because there's a minus in it, I'd change the sign, put that number in the middle of my x column, go smaller and bigger. For all the graphs we're going to do today, the domain is going to be negative to positive infinity. And if there isn't a number written after the exponent, the range is going to be from 0 to infinity. The graph is going to bottom out on one side on the x-axis. Because the base is a fraction, the graph is going to get high on the left side, low on the right side. When I go to graph this, the graph is going to bottom out at the x-axis. If the graph isn't going to touch the x-axis, it's going to stay microscopically above the x-axis. And because the base is a fraction, it's going to get high on the left side, low on the right side. I could do exactly what I did in the last video to get my y's, but I don't care to do that. Let me get my y's slickly for the rest of the videos. So if you're using this calculator and you watch the video to get your calculator set up to do tables in chapter 4, then do this. To find my y's, I'm going to hit the mode button, option 7 that says table, and now I'm going to enter the function. I'll go parentheses, left parentheses, fraction 1, use the kind of mouse arrow here to go down to the denominator, get 3, use kind of the mouse button to get out of the denominator, right parentheses, exponent key, which is the x with the square next the square shape, and then alpha button and right parentheses for x, and then -1. So that looks just like my function. I'm going to start at -1, end at 3. My numbers are 1 apart, so step 1. I'm going to hit equals now. Start at negative by the fraction in 1, hit equals. End at 3, hit equals. And because my x's are 1 apart, type 1 and hit equals. And now it's going to give me decimals as opposed to fractions. I can live with that. So it says the first point is x equal to -1, y equal to 9, or f of x equal to 9. The second point is x equal to 0, y equal to 3. Then x equal to 1, y equal to 1. The fourth point is x equal to 2, y equal to, here it says 0.3 repeating. Here it gives me the fraction 1/3, kind of as it can write fractions. So here I would either write 1/3 as a fraction, or if I did a decimal and round to 1 decimal, it would be 0.3. And then if I arrow down one more time, it says the fifth point is x equal to 3, y equal, the fraction is 1/9, or the decimal is 0.1 repeating, and that rounds to 0.1. It doesn't matter to me if you give me a decimal or a fraction. If you give me 2 decimals as opposed to 1, I'm good with that too. So those are all the numbers I need to plot. I usually don't plot big numbers, not that 9's big, but it's bigger than I care to do without graph paper. I'm going to mark up my y-axis, and I only really need to go to 3. If I wanted to plot that point, maybe 9's there. I'll kind of crudely plot that maybe. So my first point that I really maybe wouldn't plot, -1, positive 9, and then 0, 3, 1, 1, 2, 1/3, 3, 1/9. This graph, because the base is a fraction, gets high on the left side, low on the right side, and because there isn't a number written after the exponent, it bottoms out at the x-axis. It never touches the x-axis, always stays microscopically above it. So the graph would look something, I should go through the points, like this. And eventually the graph gets so close to the x-axis that you can't really see the gap between the graph and the x-axis, but there always should be a microscopic gap between the graph and the x-axis. So you should be able to do 23 from that. The next few problems, 29 is yours, 30, let's just do 29 together. So if I was going to do problem 29, immediately I look at the exponent. If the exponent is just an x, if the exponent doesn't have any adding or subtracting in it, I use the negative 2 to 2 table. So if I'm doing 29 with you, my x's are going to be negative 2, negative 1, 0, 1, and 2. Every graph that we do has a domain of negative to positive infinity. There aren't any numbers I can plug in to get undefined. There aren't any numbers I can plug in to get i's. And all our ranges are double round parentheses. They all end at positive infinity, but the graphs at the bottom have numbers that are after the exponent that aren't part of the exponent. That's going to be the start of the range. So this graph, the graph's going to have a range of 4 to infinity. And how that's going to show up is the graph won't go beneath 4 on the y-axis. So if I was graphing this, I'm going to expect my graph to have a bottom that's not the x-axis. And there's going to be an imaginary break. This graph is not going to go beneath 4 on the y-axis. The bottom of the graph will say is 4. The graph will go up to the top of the y-axis. The top is infinity. I'm going to get the y's. Well, let me do them semi-manually for those of you that don't have the table feature on your calculator. The first y, I'm going to go 3 to the negative 2 plus 4. And then 3 to the negative 1 plus 4, just changing each of the x's to, and then 3 to the 0 plus 4. Just had a light go out, this kind of sucked. And then 3 to the 1 plus 4, and 3 to the 2 plus 4. Let me not use the table feature on my calculator. Go back to the main screen with mode 1. So 3 exponent negative 2, out of the exponent plus 4. That gives me 37 over 9. That's not good for me. I can't plot that. Let me just SD it. It says 4.1 repeating, so I'm just going to say to 1 decimal, that's 4.1. And then change the negative 2 to negative 1. 13 over 3, that doesn't help me. I'm going to SD it and make it a decimal, and that's 4.3 repeating. And then 3 to the 0 plus 4 is going to be 5. And then 3 to the 1 plus 4 is 7. And then 3 to the 2 plus 4 is 13. So because the base is not a fraction, it's high on the right side, low on the left side. And this plus 4 makes the bottom at 4. So my first point that I'm going to get the plot is going to be x equal to negative 2, y equal to 4.1. And 4.1 is going to be above this dashed line because this dashed line is y equal to 4. So that first point, I go left negative 2, up 4.1. And 4.1 is just above 4. This should be a perfectly horizontal line as opposed to dipping like mine kind of dipped. And then negative 1 comma 4.3. So I go up past 4, but not quite to 4.5. Then 0 and 5, 1 and 7, and then 2 and wherever 13 is. This graph gets low on the left side, high on the right side because the base isn't a fraction. And this graph will always stay microscopically above the horizontal line that goes through 4. All of the y's will all be bigger than 4 as I go off to the left. Off to the right, they're bigger than 4, but they're not even close to 4. So that would be a reasonable graph for 29. All right, so one or two more of these. So we have just a few more left, 33, 34, 35, 36. I'll do 33 with you and then maybe not even do 35. I'll let you do 35. So if I was doing problem 33, I look to the exponent. If the exponent just had an x, I'd do -2, -1, 0, 1, 2. That plus 4 in the exponent makes me put -4 in the middle of my x column. Change that sign. Go smaller. Smaller than -4 is -5 and -6. Bigger than -4 is -3 and -2. Those are my x's. The domain of all exponential functions is negative to positive infinity that we graph. And then the range of all the graphs we do are double round parentheses. This range is going to start at 2 because that 2 is not part of the exponent. And if I went to sketch a graph of this, the graph isn't going to go beneath 2 on the y-axis. That's going to be the flat out bottom, and the graph will stay microscopically even above that. I'm going to use the table feature on my calculator to get the y's, which means I'm probably going to write some decimals down, and I'm okay with that. So the easiest way, the way I prefer you to get the y's, is like this. So on this function, if I wanted to do this 3 to the x plus 4 plus 2, I'd go mode 7, and then 3 exponent alpha and right parentheses for x, plus 4 out of the exponents, plus 2. That looks enough like the function. I feel good about it. Hit equals. Start at negative by the fraction 6. Hit equals. End at negative by the fraction 2, hit equals, step 1. And now my y's are going to come in order. The first y is just 2.1, so I'm just going to write that, round it to 1 decimal. Like decimals, they're fine to plot. My second y is 2.3. My third y is 3. My fourth y is 5. And my last y is 11. That 11 I kind of wave at as I plot it. That's enough for me to get my graph going. So first point, left 6 up to 2.1. 2.1 is above that line at 2, pretty close to it though. And then left 5, -5 up 2 1/3, which is maybe about there. And then should be over here a little bit more. And then -4 comma 3, so -4 up 3. -3, 5, and then -2 wherever 11's at. This graph is not going to touch this horizontal line. It's going to stay microscopically above that horizontal line, but eventually it's going to get so close to that horizontal line that I can't distinguish. It'll look like it's touching it because of the width of my marker. But that would be a reasonable graph for that. So give 35 a go, and then that's everything for this section. So I'll stop this video, so we just have 3 parts, and then we'll march through. We just have 2 more sections left to get done for the semester.